versus partially in advisory?
Yes.
Okay, gotcha. All right, so before we get started, let me ask you, does anybody know what these people are doing? Have you ever seen these people out and about in the world?
Is that the Google thing, like the?
Aren't they measuring something?
They're measuring something. They're called land surveyors. And they're looking at heights of buildings and certain properties and looking at characterizations of those properties. And so this has a lot to do with what we're talking about today. These people, these land surveyors, use what we're doing today a lot to help them talk about properties and their characterizations for legal reasons, for monetary reasons, all sorts of things. So if you see these people out there in the world, you'll know what they're doing after today. So let's talk about some applications of right triangle trigonometry. So what we're talking about first is something called the angle of elevation. So if a person is standing on the ground, so here's the little person, right? Here's a person standing on the ground. And they're looking up to the top of a building. The angle formed,
Dr. P.
Yes?
Ethan's joining the call right now.
He's what?
He's joining the call right now.
Okay. The angle, thank you, formed between the line of sight and the horizontal. So this angle here formed by the line of sight and the horizontal. So here's the little horizontal, right? And I'm looking up. This angle is known as the angle of elevation. So you're starting on the ground, and if you look up to a point, that's your angle of elevation. So this is my line of sight. Now, I want to say everything we're talking about, there's a little disclaimer. Now, granted, if you're standing and you're looking up, the angle is being met with, we're assuming that you're not tall at all, right? You're on the ground looking up. So technically, I should draw you like lying down on the ground, looking up, right? Because we're making that angle there. So in a lot of applications, when you're working with this, you have to take into consideration the height from which you're creating the angle. Does that make sense? So we're taking some liberties here with the assumption that the angle of elevation, that even though you're standing looking up, the angle being made is from the ground. Does that make sense? Okay. All right. So let's look at an example of where we would use the angle of elevation. A person standing 80 feet away from the building. Okay, so I have a building, just like in the previous example. And I have a little person who's standing 80 feet away. So a person standing 80 feet away from a building. So this is my 80 feet. Looks up at the top of the building. So I'm looking up. So again, I'm drawing it from here, even though my eyes are here, right? I'm not going to take into consideration. I'm looking to the top at an angle of 54 degrees. So my angle of elevation is 54 degrees. You see how I've drawn this picture from this word problem? It is saying what is the height of the building. So I'm looking for the height of the building. Well, I have some trig I can use. So I know this is a right angle. I have my angle of elevation. I have a trig ratio I can use. So again, I like to take into consideration where my hypotenuse is. So this is my hypotenuse, right, of that right triangle, my line of sight. So what trig ratio can I use?
Cosine.
You want to use cosine, but cosine uses the hypotenuse. I don't know, the length of the hypotenuse. Tangent. So if I take the tan of 54 degrees, the tangent is the opposite over the adjacent. So this would be the opposite and this would be the adjacent. And I can solve for h. So h equals 80 times the tangent of 54 degrees. So I could calculate, use my calculator to find the value of tangent of 54 degrees, multiply that by 80. So what is the height of the building? You find it, you tell me. Approximately what? 110.1 feet. That is correct. Can everybody get that? Now, if I had that, I could then tell you, you know, the hypotenuse, right? Do I know this angle here? Yeah, I could find it if I wanted to. And that might be helpful if we knew that. Which leads me to the angle of depression. The angle of depression. So I'm a little person again. I'm standing on the top of the building. And now I'm looking down. So I'm looking down. So now that is my line of sight. I'm looking down to something on the ground. The angle formed between the line of sight and the horizontal line, so this is a horizontal line, that angle is called the angle of depression. So I'm looking down. If I look up, it's angle of elevation to a high point. If I'm looking down to the ground, it's angle of depression. Now, that's interesting. We just talked about two different types of angles. Is there a relationship between the angle of depression and the angle of elevation? They are congruent. Right? And how do I know that? Alternate interior angles. Right. Because I have two horizontal lines, right? And I have a transversal cutting those two horizontal lines. So these are alternate interior angles. So keeping that in mind, if you have the angle of depression, you have the angle of elevation and vice versa. So let's look at an example. A boy climbs to the top of the tree. So here's my boy at the top of the tree. He sees his friend. Here's his little friend. He sees his little friend 100 feet from the base of the tree. So hopefully you should recognize that this is the length I'm talking about, right? That's my 100 feet. My little friend is 100 feet from the base of the tree. Now, the tree is 25 feet tall. This is a right angle. What is the angle of depression to his friend? So angle of depression is this. That's my angle of depression. Which I know is congruent to this angle of elevation. If my friend is just looking to the top of the tree. How am I going to find that? Do I know any information? I sure do. Well, that's going to tell me the length of the line of sight, right? But that's not going to tell me the angle. So I'm looking for the angle. Okay, so let's go ahead and set up the tangent trigonometric ratio and then, yes, use the inverse of it to find the measure of the angle. So I would say the tan of x, which I don't know, right? This is x, equals, tan is what? The ratio of what to? Okay, 25 over 100. Opposite over adjacent. So here's my angle. There's the opposite. This is the adjacent. So then I have x equals the inverse of tan of 25 over 100. So what is the angle measure? The angle of depression. 14 degrees. Yes. Can we get that? So think of all those little surveyors out there looking at those angles of elevation and angles of depression that can be used to find angles, heights, right? All sorts of things. Look at another example. We have two people. We have one person at point X and another person at point Y. They see an airplane at A. So there's my little airplane. We've been given some other additional information. We have been given the fact that this angle measure is 35 degrees, right? So the angle of elevation from X to A is what? 35 degrees. Do we see that? The angle of elevation from X to A with the horizontal is that degree measure. Now, what is the angle of depression? So now I'm looking at the angle of depression from A to X.
145.
How do I get that?
Because
Angle of depression from A to X.
Isn't it 35?
It is 35 degrees, right? And you are absolutely correct. I heard where you were going. These are horizontal lines. This is the transversal, right? So this angle and this angle, that's the angle of depression, 35 degrees. Now, what is the angle of depression from A to Y?
You can just subtract like 35.
Well, that would be the angle between, that would be YAX, but they actually give us this, right? Don't they give us that? They've told us that the angle of depression from A to Y is 23 degrees. What is the angle of elevation from Y to A? It is 23. Good. Right? Because that would be this. And we got that again because it's congruent to the angle of depression from A to Y. So far, so good. Emma? Now, they are asking you, is the measure of angle of elevation from Z? Okay, so we have a whole new ball games here. Angle of elevation from Z to A. So this angle. Is that greater or less than 35 degrees? It is greater, right? And we can see that. All right. Another example.
Wait, how do I know it's greater besides like C?
Well, we're looking at it, right?
Yeah, but it would be the
Well, because if you start here and you drop down and you drop down, right? This has to move this way, making the angle smaller. This is just visualization.
How would it follow the pattern of 23 is less than 35 and 35 years?
Well, that's true as well, right? Because this is further to the left, so this angle is a bit smaller than the entire thing, which I should do in a different color. Yeah, that's another way. All right. You attend a music concert with some friends. You sit halfway up the bleachers. The angle of depression from your horizontal line of sight to the stage is 24 degrees. So here you are sitting. You're looking down to the stage. Your angle of depression is 24. You see how I recognize that? Here's my angle of depression. If your seat is 45 degrees above the stage level, so here's the stage level, you're standing 45 feet above it. what is your actual distance D from the stage? Couple different ways we can do this. How would, does anybody have any idea?
Figure out what size that is.
Okay, so you want to figure out what this is or
Yeah.
what this is?
Wait a minute, why did
Or you
you
can-
highlight the, oh wait, that is different.
Wait, don't
You
we
can
already?
use signs.
Isn't it already 24? That's
You know what's
really much to the angle of elevation. And then you can use from there tan.
Okay, so what I'm hearing are two different things. I'm hearing some people telling me that this is 24 degrees, right? Because it's congruent to this. Fair? I also heard something else. If I know that this is a right angle and this is 24 degrees, I also know that, right? But let's use the fact that I have alternate interior angles and go that route. Feel free to do it the other way. We are going to get the same answer as long as we do our algebra correctly. So if I want to use the fact that this is 24 degrees, I'm looking for the hypotenuse. I have the height, so which leg do I have? Opposite or adjacent? Okay, so what is the trig ratio that uses the hypotenuse and the opposite side?
Sine
So I have sine of 24 degrees equals what?
45
Okay, and then if I'm solving for D and multiply across that equal sign. And then I'm solving for D, so what would I do next?
45 over sine.
Because that's just a constant, that's just a value. So I'm dividing each side, and I get D equals 45 over the sine of 24 degrees. And if you put the sine of 24 degrees into your calculator and divide that into 45, what is the distance? Approximately 111 feet. So my distance from the stage, because it's a word problem, is approximately 111 feet. Next example. A driveway has a 15% grade. So what does that mean? Well, first of all, this is your tangent ratio.
Or it goes up at a 15 degree angle.
Okay, so that no, it's not your 15-degree angle, but if this is your tangent ratio, how do I represent 15% as a fraction? It is 15%, cent in French, 100, 15 over 100, right? As a decimal, what would that be? 0.15. Okay, so you should be able to convert from percent to fraction to decimal in any order. Now, if that is my tangent ratio, let's go back to this 15 over 100. If my tangent ratio is 15 over 100, and tangent is opposite over adjacent, I could draw a picture. And if I'm looking at my angle of elevation to find, I'm looking for this. That is my angle of elevation. I know that my tangent ratio with respect to that grade is 15 at a ratio of 15 to 100. So everybody see how I got that? Yes.
How did you know?
Because that's technically what it means by the grade of any surface, the grade, right? How much is it increasing? That's a good question, but that's what literally it means. So what is the angle of elevation of the driveway? Well, I have that the tangent of some x, some angle, is 15 over 100. So if I want to solve for x, how would I do that? Inverse tan of 15 over 100. So what is x? What is that degree measure? 8.5 degrees. Tiny, tiny. So the angle of elevation is 8.5 degrees. Okay, so now let's go back to that information because I wasn't giving lengths. I was just giving a grade. So that's just telling me a ratio. So now I have that this is 8.5 degrees. That's a right angle. And I know that the driveway is 24 meters long. I mean, 12, sorry, my apologies, 12 meters long. So what does that represent in this triangle, that 12 meters long? The hypotenuse. Well, because this is my driveway, right? And my driveway is 8.5 degrees up at an inclination of 8.5 degrees, right? This is my driveway, and that's how steep my driveway is. Okay, so I have that's 12 meters long. I'm asking how much does it rise? So if I'm looking for how much does it rise, I'm looking for the height. Remember, rise over run gives you that slope. So I have, if I'm looking at this angle, which trig ratio am I going to use to find the height? Sine, because I have opposite and I have hypotenuse. So the sine of 8.5 degrees equals what ratio?
H over 12.
H over 12. So H equals 12 times the sine of 8.5 degrees. So we would say that the driveway rises or has a height
Of 1.8 meters.
1.8 meters. Oh, the applications. Okay, now this next example uses a lot of algebra that is going to prove to be very useful to you next year to be able to manipulate all these values. So here we go. Are we ready? There's a couple parts to this. We're going to have to utilize some information and apply some beautiful algebra skills. So here you are. You're down there. And you're watching a fireworks display where you are standing 290 feet behind the launch pad. Okay, so here is the launch pad. There's my little launch pad. Okay, you see the little fireworks being launched up in the air? There's my little launch pad. You are 290 feet behind the launch pad. The launch tubes are aimed directly away from you, right? We said they're aimed at an angle of 65 degrees. So I have an angle of elevation. $65 degrees. There's my angle of elevation. The angle of elevation for you to see the fireworks is 40 degrees. So far, so good? Now, notice that the fireworks are not directly above the launch pad because we have an angle of elevation of 65 degrees, not 90. And notice that the fireworks are not right above you or the launch pad, right? So they're further out in the distance. So what I notice is, well, and maybe or maybe not, you'll notice this too, that I have this other triangle here. I can drop an altitude down to the ground so that it's perpendicular to the horizontal ground. That's going to prove very interesting to us. So I see a couple of different triangles that I can work with. The first triangle that I want to focus my attention on, let's get a different color, is going to be this one. So I'm going to look at that triangle first. This big triangle. Okay? So if I look at that big triangle, let's look at what we have. We have U. We have an angle of elevation of 40 degrees. We have this distance here. How am I going to represent this distance? Well, I'm going to call it, well, this is an unknown X. I don't know that. But I know this entire distance is represented how? Beautiful. And I have some height H, and I have a right triangle. So what if I want to write that value of H using a trig ratio? How would I represent that? Beautiful. So if I wanted to just simplify this in terms of H, I could say H is 290 plus X times tan of 40 degrees. So far, so good? All right. Now, I also have this other triangle here, right? So let's go ahead and look at that triangle. So if I'm looking at this triangle has a base of X, an angle of elevation of 65 degrees, and a height of H. But it relies on X, and I don't know X, but I can find X. But before we do that, can we write a trig ratio that relates these three pieces of information?
Yes.
And what would it be?
You would substitute the H on that one.
Well, let's just look at this independently. But I like where you're going with this because that's exactly where the algebra is going to take us once we know X. But if I wanted to just look at the relationship here, what would it be? Equals?
H over X.
Now, once I know X, that's going to help me, right? So I can write H here as X times the tangent of 65. So this gave me, I got from here, I got from here. So we're going to keep those in the back of our heads right now. Now, to the nearest foot, what is the horizontal distance from the launch pad? Okay, so let's read this. To the nearest foot, what is the horizontal distance from the launch pad to the point directly below the ignition point of the fireworks? So I'm solving for X in that triangle, right? But you know what? I have two heights equal. I have two heights, right? If I look at each of these, and this may be a leap for some of you, but if I look at this and I look at this, those heights are equal, right? They're the same H. They're just belonging to two different triangles. If those two H's are the same, can I not set those values, those expressions for H equal to each other. They're the same h. So I can take this h, which is 290 plus x times the tangent of 40 degrees. And I'm going to put that in a big bracket because that's just a number. Can't that, I set that equal to this? Okay, so that is x times the tangent of 65 degrees. Does everybody, this is the leap. Does everybody see how those are the two different ways to represent the same numerical value? So now, this is a constant, this is a constant, this is a constant. I can solve for x. So let's see how we would do that algebraically. Well, this is just a number. Now, technically, I would not at this point find the value of the tangent of 40 and the tangent of 65 because you will be doing some rounding and you'll be perpetuating rounding errors. But in the interest of you understanding the algebra, to make sure you understand the algebra, I'm going to go ahead and do that. Personally, I wait till the end to put in the big expression and not have rounding errors. But right now, we are going to do it with the rounding just to help us with the algebra.
Are you going to show us about rounding?
Sure, if you want to, absolutely. Okay, so let me go ahead and evaluate, and you tell me, what is the tan of 40 degrees?
0.839.
Okay, you said 0. So I'm going to say 0.84. Okay, again, I'm approximating. Otherwise, I would have just left it as tangent of 40 degrees. That is equal to x times, now let's go ahead and evaluate this. What is that? 2.15? So again, instead of putting the 2.15, I would have left the tan of 65 degrees. The reason I wrote these as numbers is because now I can look to the left-hand side and I can say, ooh, this is a binomial times a monomial. So I can take this and multiply it by each of these. Now, if I had not rounded, I would have been just distributing tan of 40 degrees, that whole expression. Although it's a little bit, it can be a little messy, so that's why I'm putting the numbers in here right now.
So you say like 10, 40 times 290 and then
Yes,
40 times
yes,
x?
yes. Mm-hmm.
So if like you did round, so since like everyone is just be kind of different, would it be, is it like a range? Or,
Yes, but we just don't want to perpetuate a lot of rounding errors because remember, whatever number I get for x, I'm putting back in to get h. So that's even more rounding errors, right? So let's say I did this 290 times 0.84 plus x times 0.84 equals, and I can put this first if I wanted to, right? It doesn't matter. Now I'm solving for x. So I have two terms that have x's on it. So maybe I had to get all those x terms on one side of the equation. So to move, I would maybe move this one over here. It doesn't matter where you move them, just get them on one side of the equation. This is gone. So that is going to leave me with 290 times 0.84 equals 2.15x minus 0.84x gives me how many x's? 31x, yes? And then 290 times 0.84 is what? And last step to solve for x, just divide each of them by 1.31. So what is x, approximately? I'll just put 186. Yeah. So I now have that X is 186 feet approximately, right? So this is this. So I know I'm standing, right? That far away from being right underneath the. Now, ultimately, I was trying to figure out, okay, so here this question is saying, what is the horizontal distance from the launch pad to the point directly below the ignition point? The answer to this is 186 feet. Isn't it? But the next question says, what is the height of the fireworks when they ignite? So what is H? I don't care where you put it. Well, I need this or this. I don't care which one you use. They equal the same thing. So I'm going to just do this one because I feel like it. Right? We said X was 186. 186 times the tan of 65 degrees is what? You tell me. How high up are those fireworks? Approximately 309. So the fireworks are approximately 399 feet from the ground. Yes.
Can you show us how we could solve that if we didn't use the decimal?
Yes. Okay, so if I didn't, let's go ahead and look at that. This would be, from this row, it would be, we started with 290 plus X times the tangent of 40 degrees equals X times the tan of 65 degrees. So then I'd say 290 times the tan of 40 degrees plus X times the tan. It's the same thing. I'm just actually just leaving the tan, the tan in there instead of putting the decimal approximation. I'm sorry? Well, we're not done yet. And I'd factor out my X. Okay, so then I'd put this entire expression in the calculator, 290 times the tangent of 40 degrees, close parentheses around that. You'd have to put a parentheses around this whole thing, divided by, and then a parentheses around this whole thing, because the calculator performs the order of operations. So if you don't have parentheses, it's literally going to divide that one term by the other if you do not enclose the entire parentheses. You will get the same answer, but maybe, you know, a few decimals off. Or depending on how much we really rounded, it may be 1 or 2 units off, right?
So do we need to worry about, or sorry, do we need to do that?
What?
Or like, the thing with just tangent?
Well, I mean, it's the same exact thing. The only difference is I didn't substitute in.
That tan minus,
Minus. Here?
Yeah.
Yeah, it's a minus sign. So we'll get the same thing for X. Did you get it? You will. So there is a problem very similar to this on the homework. No, because we have one more thing we have to do, but I have to tell you about it first.
got 186.4.
And we got 186.
Oh.
Woo! Look at that. That's exciting, huh? All right. Those of you online, I'll tell you about how you're going to do this online.